Okay, this is going to be the Algebra 2 sample test for statistics. For 2015, this is going to be a little bit different than last year's version because there's going to be some new calculator stuff. I've done some of this already, so I want to sort of fly through it. Does this graph appear to be normal? No, because the mean doesn't equal the median, which equals the mode. Since that's not true, that's why it's no. What is the z-score of the test? Now, the formula for z-score is z-score equals the item minus the mean. That's what mu is, divided by the standard deviation. So my test score is 97, my mean is 77, and I get that from there. Divided by 13.7, that gives me 1.45. In general, what does it mean if your z-score is negative? Here's the idea. In a normal curve, the mean cuts the middle. Greater numbers in the mean are to the right, so the z-score will be greater. To the left, they're going to be less than. What is it? What is the z-score of the mean? Well, if the mean is the same as this, if these numbers are the same, like 77 minus 77, that's 0. That's why you get that. In a normal set of data, what percentage falls below a score of 1? Now, here's how you do that. All right, go into your calculator and go to Stat. Okay? We're going to select Distribute. We're going to select Normal. We're going to select the one that says NCD. Now, in your calculator, if you're using a Casio, you've got to turn this, there's a variable list button. Make sure it says variable, okay? Make sure it says variable, so you'll be able to click down here and make sure it's variable. Now, if it's below 1, I'm going to use a really small number, which is that, even though that looks big, since it's negative, it's very small. The upper is going to be 1, okay? The upper is going to be 1. My standard deviation will be 1, because in a normal curve like this, the standard deviation is 1, and the mean is going to be 0. So if I go down to execute and hit calculate, the P stands for probability. Okay? So if my probability is 0.841, if I multiply by 100, that's like 8.13%. Okay? Or 84% if you would. Okay? If distribution is normal, what is true about the relationship between the mean, median, and mode? They are the same. Okay? What is the total area under the curve? 1. Okay, that's just a property you have to know. Abby and Bobby got their z-scores for their test. Abby is a negative 1.2, and Bobby is a 0.7. What does that tell you about Bobby and Abby's SAT results? All right, now, since the mean is here, you know, Bobby would be like right here. Here's Bobby, okay? That's Bobby. Abby, since she's got a negative z-score, she'll be over here, okay? So we know Abby didn't do better than Bobby because if you go along this line, this is better. Abby is closer to the average. No, that's not true. 0.7 means you're closer to the average. Abby did better than most people. That's not true. Bobby did better than Abby. That is true. Bobby is closer to the mean, okay? And Bobby did better than most people. All of those are correct. Okay? Describe how the mean and standard deviation will affect the graph of a normal distribution. Okay, so if your mean, let's say I have a line here, all right, and I got a bell curve, okay, all right, and let's say I have the same mean. I'm going to put this in 2 different colors. If I have a graph that is more spread out, okay, with the same mean, the red would be a greater standard deviation, okay? The other thing you should know is that if the graphs go like this, I'm going to use a different color, say green, okay? The green would have a greater mean, okay? Because the idea is you treat this like a number line. So this is further along, down the number line, okay? So if you looked at a number line, you know, you would keep getting bigger as you went, all right? All right, it says a national aviary has 236 birds. The average weight of a female bird is 20 ounces. What is the standard deviation? The standard deviation of 1 ounce. Approximately how many birds are over 21.5 inches? Okay, so let's go back into this, okay? Now, since it says over 21.5, the small bound is going to, the lower bound is 21. We want to be the bigger side because this is how many more. So I'm going to do a positive 999, okay? The standard deviation is 1 ounce, and the average weight is 20 ounces, okay? So my mu is 20, okay? Let me go back. So my mu is 20, all right? That's my mean. Standard deviation, all right? So then when I hit, I go down here to hit execute, it's going to tell me 0.066. So I'm going to use a couple of these. So 0.066 is the probability. I'm going to multiply by the number of birds, okay? Because it says how many birds. So I want to multiply that amount by 236, okay? So I'm going to go over to here, and I'm going to do 0.066 times 236, and it's approximately 15 to 16 birds, somewhere in there, okay? It says the average calf weighs 90 pounds at birth with a standard deviation of 9.2. Dusty Lane Farm will have 300 calves. How many calves will we weigh between 75 and 130? So the idea here is 75 to 130. Here is what I want. I want that interior part. Okay. Once again, I go back into stat. Okay. All right. Back into distribute, normal CD. Okay. Now, what I want to do is I want to go 75 to 130. Okay, because that's where I'm going to be. It says the average calf weighs 90 pounds, so I'm going to use that one. And then it says a standard deviation of 9.2 pounds. Okay, so that's my stuff there. I go ahead and find the probability. Probability is 0.948. Okay, so 0.948 is my probability times the number of calves. In this case, I have 300 calves. Okay, and that's going to tell me what my answer is. Okay, so if I go back here and I do 0.948 times 300, I get an answer of about 284 calves. Okay, all right. Now it says a standardized test is a mean of 425 and a standard deviation of 50. Draw a picture of the normal curve showing 3 standard deviations to the left and 3 standard deviations to the right. Shade the area that represents that score. Okay, so here's the idea. Here's the idea behind standard deviation. If my mean is 425, standard deviation is 50, so that's going to be 475. So all I did was I added 50 to that number. Then I do 5 1/4, and then I do 575. Okay, going the other way, it's 375. Okay, so I'm going to subtract 50 going the other way. 3 1/4. Okay, and then 275. And what they want me to do is shade between 375 and 5 1/4. So I would shade them just like that. Okay? All right. Determine the probability that an event has a z-score between negative 1.1 and 2.52. Draw a normal curve and shade the area to help find your answer. So the idea is if it's at negative 1 and 2.52, I'm going to shade right in here. Okay? And once again, they want the probability. Okay? They want the probability. So I'm going to go back into the stat button. Okay? Distribute, normal CD, so I'm going to do negative 1, okay? And then I'm going to do 2.52. Now, since this is just a regular generic, I'm going to use 1 for my standard deviation and 0 for my mean, okay? Go down to execute, and it's going to tell me my probability is 0.835. 0.835 is my answer, okay? And since it's a probability, that's all I want. It says the scores of the National Assessment Progress Mathematics tests are approximately normally distributed. The maximum score on the test is 600. The mean of the scores of a recent test was 320. That's what mean means. The standard deviation is 38. What is the probability that a randomly selected student had a score greater than 385? Okay, so I'm going to go back to here. Greater than 385. So 385 will be the lowest number. The biggest number is going to be 999.9. Okay, the standard deviation they're telling me is 38. The mu is 320. All right. Once again, go down, execute. So my probability is 0.043. Okay, that's the probability. All right. Then it says determine the probability of a randomly selected student who took a score less than 300 and greater than 400. So once again, this is like sort of a dual one. Now, here's where you have to be careful. We want to select this part and this part. Now, what we do to make this easy, we're going to find this and do 1 minus that probability. okay? So the idea, very simple, let's go back, I always have to do exit. Instead of doing this range, I'm going to do a range between 300 and 400, all right? All right, same, all that stuff is still the same. Okay, so I got 0.683. So what I'm going to do, because I want to find the area on the outside, I'm going to do 1 minus 0.683. Oh, whoops. Let me go back in here. 1 minus 0.683. All right, and I get 0.317. Okay, 0.317. All right, what would you need to get to be in the 60th percentile? Now, what you're going to do is when you go into stat, you're going to do something a little different. You're going to go into distribute, normal. Now we're going to go into this one right here. It's the inverse one. Okay? All right? So we want to get to be in the 60th percentile. All right? So we want to go left tail. All right, 60. All right, we're going to go down and execute. Oh, I'm sorry, I think I want a left tail, but I want 0.6. Okay? I would need to get a score of 329 to get that. All right? I would need to get a score of 329 to get that. So all you had to do here was, when you went to the inverse normal, do the left tail, you want 0.6 to the left, same stuff, all right? And that's how you get that one. The lengths of the car wipers are normally distributed with a mean of 25 and a standard deviation of 0.2. Find the probability that it's between those two. Once again, it's between. So what I'm going to do is I'm going to go back to distribute normal. I'm going to go back to my normal one. So I'm going to be between 24.89 and I'm going to be between 25.11. Okay? All right, now in this case, the mean is 25, so I'm going to do that one first. All right, sometimes double check this stuff to make sure you're right, and that's going to be 0.2. So I'm going to go down and execute. Now the probability is 0.417, okay? 0.417. All right, from 200 wiper blades, how many would we expect it to be 25.7 or more in length, okay? So now, we want more, all right, more. So when I go back into this probability here, all right, now I want to be bigger than 25. So the smallest amount I want to have is this. And what I want to do is I want to do 99999, all that same stuff there, all right? So when I execute, the probability is 0.066, okay? So I got 0.066. Now this is a number, so they want how many. So when they want the how many, you got to multiply, all right, the probability, okay, this is key, the probability by how many, all right? That's how you get that answer, all right? All right, how many they got? So I'm going to go 0.066 times 200, okay? And that's about 13 wiper blades. 13 wiper blades are expected to be above that, okay? All right, the time it takes by a garage to replace some worn out brake pads follows a normal distribution with a mean of 90 minutes, a standard deviation of 5.8. What percentage of the time does the garage take longer than 105? So once again, when we go back into stat here, longer would mean greater, okay? So longer, we went 105 and going this way, okay? So that's going to be all that stuff right there. So what I want to do is a distributed normal that. The minimum I want is 105 minutes. The biggest I want is still that 999 because I want more, okay? All right. Now, it says the standard deviation is 5.8. The mean is 90, okay? So if I go down here and calculate this, okay? All right. It basically, what it's saying is that it's almost, if it's very small, it's almost zero, okay? All right, that it's going to be that, it's almost 0%, okay? Is what is the probability will be that. Now the reason that is if you look at what 3 standard deviations away, let me double check to make sure I typed that in there correctly. All right, so 90 minutes, 105, standard deviation of 5.8. Yeah, I did do that right. I calculate that. The probability, I think, is actually going to be 0.004. Okay, maybe not quite 0. Okay, but 0.004. 0.04. Yeah, that's a 1, 2, 3. Yep. All right, so when you get that, be very careful. That's what that means. All right. Now, how to figure out the percentage there, 0.004 times 100, all right, is about 0.4%. That's a very small number. Okay. It's basically about 0. What is the probability it'll take less than 85 minutes? Once again, 85 on that deal, 85 would be all the way this way. So what we want is a very, very small number. So when I go back into stat, all right, I want a very, very small number, normal, all right. I want my lower one to be like negative 999. I want that bigger one to be 85, okay. All right, I'm going to go down and calc, okay. So that's 0.194, okay. 0.194 would be that probability, so understand that difference. What is the area of the shaded region, okay? All right, so the area of the shaded region, all right, very simply, okay, it's a little bit more than the mean there, all right, and what it's saying here is that if it's negative 0.65, so basically all of that, 50%, would be all the way over on that one, okay, all right, and you want to find if the z-score is this, okay, if the z-score is that, so basically you're somewhere, you're not quite to 1, okay, so what you could do here if you wanted to, actually the simple way for this, okay, if you wanted to find the area, let's go back and do, we're going to do negative, lower bound of negative 0.65, okay, the upper bound will do 999. Since this is normally a distributed one, we'll have 1 and, we'll have 1 and we'll have 0, okay? So if I go down to calculate, okay, and execute that, all right, that's going to be 0.74, would be 742, would be that shaded region. Yeah, I wasn't thinking about that for a second. All right, use the diagram to compare this, okay? So here's the idea. B, C, and D, since they're all on the same point, all have the same mean. So B, C, and D have the same mean, okay? A mean is smaller, okay? All right? Now, what's nice, the idea is the wider they are, the bigger the standard deviation. So which curve has the highest standard deviation? That's going to be the widest one. That's going to be D. Which curves have the same mean? We just discussed that, B, C, and D. Which has a mean greater than A and C, okay? All right, I don't see any that have none, okay? Which has a greater mean, A or C? C's got a greater mean. Which has a greater standard deviation, okay? That's going to be C because it's a little wider, okay? On the axis below, draw a normal curve with a higher mean, same standard deviation. So what you want to do is you just want to move this down and basically create the same graph. Okay, I'm not a very good artist, so that's the same graph. All right, what's the characteristics? Okay, all right, 68, 90, 95, 99.7 distribution. Okay, it's symmetrical. Okay, all right, the mean equals the median. All right, equals the mode, and the area under the curve, area equals 1. Okay. All right, those are the 4 characteristics. All right, your class is conducting, let me see how much longer we got on this. Nope, I think this is the last page. Okay, your class is conducting elections for president, vice president, treasurer, activities coordinator. There are 150 people in your class. How many different arrangements can there be with officers? Now, order matters here. When your order matters, you use a permutation. Okay, so what I want to do, all right, let me go back to this. All right, I want to go to option. I want to go to option, use F6, probability. So I want to use P. So if I want to choose, how many people I'm choosing? 1, 2, 3, 4, and 5. So it's 150, and I want a permutation to choose 5 because obviously the order matters. It's a very large number. So that's going to be 7.0 times 10 to the 10th. 7.09 times 10 to the 10th, okay? All right? At a cattle cutting contest, the rider must separate 6 groups of cows from the herd of 50. How many? Now, see, in this, you have set positions, okay? Set positions. This, if you look at this is just picking 6. Okay, I'm not putting them in a set spot. I just got to pick 6. So in this case, I'm doing 50, choose, okay? I'm going to choose 6 cows from that. So that's 1, 5, 8, 9. Okay, 0770 or 0700. Okay, all right. I have 7 different fruit bars to last the week. And how many different orders can I eat those? Okay, so here's the idea. I believe what this is trying to say is you're going to eat 1 a day. So 7P1 because there's a select spot. So Monday would be a spot, Tuesday, whatever. Okay, so that's what I'm going to assume. Okay, so 7P1 gives me 7 ways to do that. Okay, a game has 8 different cards and 3 colored chips. A player is dealt a hand of 4 cards and chooses 1 of the chips. Calculate the numbers. Okay, so basically these are both combinations. So I'm going to do 8. All right, I'm going to do 8C3. And then I'm going to multiply that result by 3C1. Okay, so I'm going to figure out what 8C3 is. 8C3. Okay, 3C1. And I'm just going to multiply those values. Okay, that's 168. Okay. All right. A model has a center offers tile, wood, carpet. Offers wood, tile, or carpeted floors. 20 shades of paint for walls, and 5 styles of rooms. How many different rooms are possible? So basically there are 1, 2, 3 options here, 20 and 5. Okay, so you're going to 3C1 times 20C1, and then times 5C1. Okay, so you're going to figure out what all these are individually. Okay, all right, we're going to have 3C1, which is 3. Okay. All right, 20C1 I believe is going to be 20, but let's double check. 20, all right, 20C1, okay, is 20, and I believe that's going to be 5. 5C1, it's 5. Okay, so that's 60 times 5 is 300. Okay, and I think it's the last one. In a lotto, there are 5 distinct prizes located to 30 random participants. How many different number of combinations? Okay, all right. So since it says distinct, okay, all right, that order is gonna matter. So I'm gonna say 30P5. The word distinct sort of gives that away. So I'm gonna do 30P5. And the answer is 17100,720. And that's the answer there. Okay, and I believe that's it. And that is it. So go ahead and go through that sample test, use that calculator, understand how to do those methods, and you should be fine.